Okay, so like we have discussed this before, but let's just quickly go through it. Logistic regressions, right? So logistic regression is it's a regression, but we use it for a classification method. Classification by passing the output of a linear regression to a logistic function, which gives me a value between 0 and 1. Right, that's the whole point. So any output, any value that you are getting, any value between minus infinity to plus infinity, you are getting some values, but you want your output to be between 0 and 1, so that you can assign it to either one of the classes, whether he has cancer or not, whether this is a cat or a dog, if it is an image, or whether this guy is pass or fail, right? So for example, suppose I want to allocate passing or failing this tag to students. So I will say if the marks are greater than 40, then he's pass. If the marks are less than 40, then he's a fail. So to record data, I should not be using an integer variable, right? I don't want to know 89, 98 or 100 marks. I just want to record pass or fail, pass or fail. So whatever is the output, what is the final mark of the student, I will pass them through a logistic function, which will give me a probability between 0 and 1. And based on the probability, if it is more than 0.4, like for a particular case, if it is more than 0.4, he is passed. If it is less than 0.4, he is fail, right? So it can be used in like it is already used in this spam email detection in our web emails, or loan default. Loan default means whether this guy will pay loan or not, or whether you have coronavirus or not. Such a situation we use logistic regression, because like if you go for a parameter for a test, corona test, as of now we will get some. So how do we know whether we have yes or no? So if you have gone for any blood test like SRL diagnostic, you get a report, and there are some names, and against the names there are some numbers, right? So it's, and there is a limit. If you are out of that limit, then there is some problem, otherwise it is fine. So similarly for corona test, we put something in our noses, then we put that swab into that particular test tube, small test tube like thing, and after like 30-40 minutes, I'm talking about the antigen test, it gives me a color, and based on the color we know whether it is corona positive or negative. So basically some whatever material is there inside our nose, that particular thing goes under a chemical reaction, and we get a kind of a reading, right? Some number, which in our case is the color. If the color is red, then you have coronavirus. If the color is not red, then it is not a coronavirus, right? So we are not interested in the particular value or that number. Okay, suppose there is some particular enzyme which tells me I have coronavirus or not. So I don't want the particular number. So your number is 45, your number is 83. I don't want to know that. I just want whether I have coronavirus or I don't have coronavirus. So for this, I use a litmus test. Litmus test means just a color. Okay, if your color changes to red, you have coronavirus. If it doesn't change, you don't have. So it's a binary classification. Same thing can be applied to a regression using a logistic function. How is like this? So like a line will give you all sorts of values like this, right? So like you can get values here also, and you can get values here also. But for our particular case, I just want values between 0 and 1. So this case may fail, right? So I want a curve like this, logistic regression curve. This curve will only take values between these two. This is because of mathematics, because of the type of function it is. We will see like in the next slide. So like for whatever value you input, it will always give you values between 0 and 1, right? So this is that function, 1 upon 1 plus e to the power minus z. So whatever value, for any value of z from minus infinity to plus infinity, the output will always be between 0 and 1. That's the beauty of mathematics. It is called sigmoid function or logistic function. This can also be asked in a interview, like what is a sigmoid function? Why do you use it? Right? Simple question. But like, or what is a logistic function? Right? So they are the name of the same thing, sigmoid or logistic. Right. So basically my y's from the previous derivation, from the previous concept, linear regression, is this one. Like this is this is my model, but this y can take any value. But for logistic regression, I want this y to take only values between 0 and 1. So I will pass this particular thing here, right? And the output will be 0 and 1. So I'm basically, if you want to understand this figuratively, I'm converting this straight line into this particular curve. That's all what linear logistic regression does. So it gives me a probability between 0 and 1. So I can ask them to I can ask, so I can now when I have a probability, then I can decide whether which class it should fall into. So by default, I can decide the class cutoff to be at 0.5, 0.05, sorry, 0.5. But if it is something else, you can decide based on that, right? Suppose for an example of that student passing or failing, this cutoff will be at 0.4 or 0.3. Based on my requirement, I can decide the cutoff. If it is general thing, like if I'm just asking about the gender, like based on the photograph, tell me the gender, then the cutoff should be at 0.5, right? For any other case, or so it depends solely upon your problem and the domain that you are working with, right? Suppose I'm working with some we will see in the next slide. Suppose you're working with this breast cancers, right? So if the size lies, so I am keeping the cutoff at here. So only for these many things, they are like, they do not have cancer. For all of these values, they have cancer, right? So the cutoff is set as here based on the diagnosis, based on the domain, like because doctor will tell us, we are not doctors. So doctor will tell us, okay, if this probability comes out to be this, or there has to be a cutoff size, right? So logistic function will tell me, so like if the size is any more than 100 in 100 units, then it should be called a cancer, right? So then suppose based on the function, the 100 value comes over here, so my cutoff will become this particular value, maybe 0.1, 0.2, like that. Okay, so we use the logistic function to output a value ranging from 0 and 1, and based on this probability, we assign it to a class. So we use logistic function for classification, right? Whether a spam email or a ham email, whether a boy or a girl, whether a cat or a dog, whether a loan should be approved or not, pass or fail, like that, binary classification. Right, then so this is the same example I was talking about. So there is a tumor size, and I want to tell whether it is malignant or not. Malignant means whether it is lethal or not, whether you will die or you will survive, right? So if I fit a linear regression, because the sizes may vary, so the size can be like this, or a bigger size can be like this, right, of tumor. So if a line is like, if I'm reading a line like this, then all of these points will be considered non-malignant, but that will be a wrong diagnosis, right? So that's why a linear regression fails in particular case. So for such a situation, I need a more continuous curve like logistic regression, right? So for this particular, so if this is my diagram, if this is the data distribution, this model works. But if this is my distribution, there are like some values over here and some extreme values over here, then my linear regression will always try to fit this particular data, right? Because of by design, the linear regression will try to minimize the error, right? So a better line will be this one, but to minimize the error, my line will become like this. So all of them will become non-malignant, but that is not true. So that's why I need a logistic regression, which gives me values between 0 and 1, and it properly accommodates for all sizes of tumor. Okay, this is what a logistic regression is. Yes.
Now I was about to ask that time only. So somebody asked a question for me. Is it linear regression, logic regression, and KNN and decision tree? Out of three, which are biased or which are variance?
Which are biased
and which are variance?
Variance. I'm not able to completely understand the question. Like, which are biased or which are variance?
Algorithms are biased and which are varianced?
Varianced.
Yeah.
All of Sujan, all of the algorithms has a variance, and bias is also there.
But bias is not there in linear regression, right?
No. Linear regression, the bias is there. That intercept value is the bias. In linear regression, this intercept is the bias. This intercept, this is the bias. And variance is that, like, how much your values are deviating from your actual value.
How do you define bias?
So bias,
Like,
suppose. So like in the last class also, I think I have explained this. Like, so suppose your data is like this. This is your data, right? So if I choose this line, then so I need to change the angle. So like suppose this line fits it, and then I have to move it across the y-axis, right? So bias is the initial deviance or initial initial configuration that my model needs to have in order to fit the given data completely. Okay, so it is the kind of maybe like to explain it in other terms, what can I say? So have you I don't know, have you like driven a bicycle which is like kind of squinted, like tilted towards one side? So it's like a counterbalance which you need for your model to fit the present data, because linear regression is just a straight line equation. In order to fit different data distribution, I need to shift it across the y-axis, right? So by the amount by which I'm going to shift it, like so suppose this line or this line, so this amount is called bias, because when x value is 0, what is my y value? So like before starting anything, there is an initial bias towards this particular thing, right? This is called the bias in a linear regression. Okay, and the same thing goes ahead with like other things also. Like so so the bias term takes care of the configuration of the shape of the distribution. And variance is like we have a specific formula. It gives you a measure of how your predicted values are spread across all the values, right? So how your observed values are differing, or what is your variance, right, with the mean. So let me just, so it's like suppose these is my data and this is my line, right? And I have one more example where, can you see these? Right, so we can clearly tell that there is high variance over here and there is very low variance over here, right?
That is a distance from the mean to that particular.
Yeah, mean to
point,
then particular.
right?
Yeah, yes, variance. So, and the other meaning of variance is that if I completely remove all of these data points and I bring in new data points, then will my model change? Okay, so basically I'm saying like this is one more you can say, and different suppose this is my model and it is fitting properly on the left hand side I'm drawing to this particular data, right? It is fitting this particular data, and now I remove all of these 4 points, right? I removed all of these 4 points. Now I bring in new set of points, only training points only. Now how much my model will change, right? If my model needs to change a lot, that means my model has a lot of variance. That means my model will vary according to the data it is trying to fit in. Okay, input
That's
data.
what.
So it will change according to the input data. But if the variance is less, that means my model is very stable, right? So if my model is like this, like it is fitting for these values, and if I remove these values, if I bring new set of values, then also like my model remains more or less the same. There is not much deviation in the data in the model or the equation of the line. Then my model is supposed to have less variance. It's said to have less variance. Means like how much it is susceptible to the new data
Which
points.
are those models?
Huh? So I think
Algorithms.
so
Which are
in
those?
between logistic regression, linear regression, and KNN, right? So I think variance, because so if in KNN, if I'm defining the classes myself, like number of classes I want to classify, then KNN has less. So this I think logistic regression and linear regression. So logistic regression has low variance and low bias. Linear regressions have high bias and high variance, and this KNN have low variance and high bias, because we are choosing the neighbors and it is not going to affect once we are fixing the classes by ourselves. This is what I think. So KNN has high bias, low variance. Logistic regression has low variance, low bias, and this linear regression has high bias, high variance. And we need to confirm this.
Trying to say
Okay.
that we use the KNN algorithm Even though if there is any changes in the training data, the model will be there. The same model will work.
Yes, 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 yes.
That's what I'm trying to say, right?
Yes, 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 yes.
But that will not happen with respect to logistic regression and linear regression, right?
No, that will happen with logistic regression, but will not happen with linear regression.
Not happen with the linear. Logic regression, it will happen. Okay.
Yeah, it will happen.
But
Yeah.
in bias, if the bias is more in, is that going to be a problem, or that is that okay?
If the
I want to be
bias
more
is
technical. More. I was very much confused with that.
okay, if the bias is more, if your training data or your data distribution is not changing much, then bias is not going to be a problem. If it is changing like huge amounts, then bias is obviously going to be a problem, because to accommodate for new data, bias may cause a problem, right? So suppose this is my distribution, normal linear distribution, and these are the present data on which I have set up. I have this. I have modeled this. Now a new value comes up, and which the value is here. I want to predict for these three values, right? I can clearly see like the line is fine, but it should pass from here. Oh, sorry, like this. So this bias will actually cause problems. So if I'm getting values which are near to this, or the distribution is coming from the same sample, then I should face no problem, right? If I want to generalize it over a bigger population, then I may face problem. That's why there is an issue with this issue we face with logistic linear regression, and the same issue we face with KNN. Like same thing. If I want to cluster into, so this thing is one cluster, this thing is another cluster, right? So we will look at KNN. So like these are two clusters, and suppose new value comes over here or here, then there will be a problem whether to assign to this or to this. And if I do any assignment, my cluster definition will change based like this, right? So
Yeah,
like
yeah,
it is,
correct.
yeah. So like nice questions. So John, you keep these answers for now, but let me confirm them once again, and I'll get back to you more on this one, like bias and variance.
I
Okay.
think if you take a data set and if you work, that will be clear data.
Yes, 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 yes.
Same question.
Let me note it
Thanks,
somewhere.
Vinay. Thank you. Sorry for
Yeah.
disturbing. We'll
No,
continue.
no, it's fine, it's fine. Bias. Let me just note it. Yeah. So this was about logistic regression, and so this is a difference. So in a linear regression, we have to make model like this, where like this is my y function or a hypothesis. It's a function of x1, x2, x3, x1, x2, x3, x4 are the features or different columns of my data set. And for a logistic regression, this is my function 1 upon 1 plus e to the power z, and this z is the same thing as the output of a linear regression, right? And now how to evaluate a model? We have a confusion matrix, right? So what are the actual yes and no's, actual classes based on the predicted classes? So we have something called true positive, true negatives, false positive and true negatives, right? So we have to based on the number of false positive and true negatives, we calculate what is my accuracy, precision, uh, mm, recall, like that. So we have a set of parameters, right? So basically we have to look at particular these 2 points, like this should be high and this should be high, these 2 points, right? Yes, yes, and no, no. And these two should be zero in an actual case, but they are never zero in an actual case, so they should be as low as possible. False negative should be minimum, false positive should be minimum, right? Because we will be using in the code this confusion matrix only to check the performance of our model, right? So false type 1 error is called false positive. False positive means falsely predicting positive when in actual it is negative, right? That means doctor saying to a male that you are pregnant, but in actual he cannot be pregnant. And type 2 error is false negative, like a doctor saying to a pregnant woman that she is not pregnant, but in actual she is pregnant, right? This is false negative. Now next, yeah, so now we can finally move on to the topic for today, which is KNN. Right, can you see the slides?
Yes, sir, we can see.
Yeah. So like KNN is stands for K nearest neighbors, where K is a natural number, and most preferably it is an odd number. Okay, I will tell you why. So if you understand this picture, so that's the whole gist or whole summary of KNN, K nearest neighbors, right? So there's a saying that any person is the, like, personality wise, he's the average of the top five persons he spend most of his time with. Okay, so if you spend so there are five best friends, and so your nature wise, character wise, you are the average of all those five persons, right? So one of your friends is very sporty, the other friend is the like into total nerd, he reads books and he watch movies, the other guy play video games. So there is a high probability like you will be the average of both, like you are into playing games or you are into reading books by that, right? So like that's a hypothetical example, but that's the whole sole point of this particular K nearest neighbors. So and K nearest neighbor is a classification, right? So you cannot use this for predicting the price, marks, weight, height, or the stock prices. So for all that you cannot use this. You can use it for a classification. Okay, whether this is a spam email or not, whether this guy belongs to class A, class B, class C, which kind of flower is it, which kind of stocks are these, high value stocks, low value stocks, or medium value stocks, right? So whether this picture is of a cat or a dog or a lion. Okay, so you can use K nearest neighbors for classification. Okay, so show me your friends and I'll tell you who you are. So this is the whole soul of K nearest neighbors. Now let's look at in a more technical standpoint. Right. Suppose this is the data point. This is the distribution like weights and heights. This is the same we did when we did the intro for machine learning. Right. So based on the heights and weights, I'm plotting some animals, namely two animals like a dog and a horse. Horses and dogs. So blue ones are dogs and the red ones are horses. Right. I'm plotting them on a chart. So like by logic means domain knowledge. Domain knowledge is what? Biology. I have seen dog and horse. So horses are taller and heavier. So all the points over here should be horses, right? All the points in this particular region which are high in weight and high in height, are taller and heavier are horses, should be horses, and all the ones in this particular of the part of the chart should be dogs, right? So this is something I know by logic, by domain knowledge. Then what, suppose there is a point over here, unidentified animal, then what should be your intuition based on this particular distribution? Of course it should be a dog, it should be a horse. If the point is over here, it should be a dog. But what about a point which is here lying on the boundary somewhere? Okay, some kind of like a huge dog, or a very weak horse, where how should you classify that if you don't know but the type of the animal, but you know the height and weight? So if you're lying in this region, how can you classify that? So for these other 2 points, it is very easy. Like I will just look at all the neighboring points. Yeah, so he has to be a dog, and all the neighboring points for this one, he has to be a horse. But for this one, half of them are horses, half of them are dogs. What will I do? So here I'll make use of KNN algorithm, right? So it's very simple. Like you can just so of course there is no point of telling this. You store all the data, then calculate the distance. So here by neighbor I mean for data points which are close to each other in terms of the distance as in x-axis and y-axis, right? So the distance formula is same, under root of x minus x2 minus x1 square plus y2 minus y1 square, normal Euclidean distance that we saw in mathematics in school days, same distance. So like in school it was x-axis and y-axis, and the x and y both were lengths. Here they are the feature values or the parameters. Okay, so calculate the distance from x to all the points in your data. Sort the points in your data by increasing the distance from x. Predict the majority labels for k closest points. Okay, so in our example, we wanted to predict, like, but for this particular value, I will find the distance of x to all the points in your data, right? So I will find the distance from this point, this point, this point, this point, and this point, right? all the points I have found a distance. Now, so like suppose this distance is huge, this is less, and this distance is huge, this is huge. So I will set a limit that how suppose I want to look at 5 closest neighbors or maybe 3 closest neighbors. So I will choose only the top 3 neighbors, like this one, and maybe this one, right? And I will check the classes in which they belong. So like this is a dog, this is a dog, and this one is a horse. Right now, I will say like 2 of the neighbors are dog, one of the neighbor of this particular data point is a horse. Then by voting, I will say this particular data point is a dog, because it cannot be half dog and half horse. So it has to belong to any one of the classes. So that's why I take the number of neighbors to be odd, so that I never get a situation where the votes are equal. Okay, so I will always have a majority votes, right? So there are two things: how many number of neighbors you are looking at, and what is the distance, the number of votes. So predict the majority label. Majority label is the majority vote of the k closest points. So I will take what is the majority of label of the 3 closest points. So the majority of the label is D, because 2 of them are dogs, one of them is a horse. So here I will assign this particular point to dogs, this group, right? So now let's see how choosing a value of k affects the distribution, right? So this is my point which I want to classify. Now these are, so currently I have just 2 classes, class A, class B. B is in purple, A is in yellow. Now if I'm talking about 3 nearest neighbors, then I can easily say like this is the first neighbor, second neighbor, third neighbor, and majority of neighbors belongs to class B. Then this star should also belong to class B. Fine, right? For as of now, my classification looks nice. But what if I change the number of neighbors to 6? Then the situation changes. Now I am looking at uh, 6 neighbors, right? So one neighbor, second neighbor is purple, third neighbor is yellow, fourth is yellow, fifth is yellow, and even sixth is yellow, right? Why is there a circle? Because nearest neighbor I want to have 3, so I will make a smallest circle where I get 3 neighbors, right? Here I get 3 neighbors, here I get 6 neighbors in the bigger circle. So according to k is equal to 6, this thing should belong to class A, because there are 4 votes from class A, right? So we should always keep in mind what value of k we should use. And yeah, k nearest neighbor, the k. One more question is that people can directly ask you what is k nearest neighbor and what is k in nearest neighbors in that algorithm. So you have to just quickly say number of neighbors. Okay, now I'll take the same example, horse versus dog. For k is equal to 1, I'm getting this kind of a distribution, right? So there are some points over here which are in the red, these are also in red. So there is some uncertainty. But when I do k is equal to 5, it becomes more smoother. Like there are no uncertainties here. They are being clearly classified, because we can think by logic that more number of neighbors, you should take into account higher number of neighbors, right? Because that will give you a better choice. Suppose like I have 3 friends who all play cricket, who all like cricket. So you will say, yeah, Vinay will also like cricket. But if I talk about my 10 closest friends, 7 of them like football. Then your idea will change. Okay, no, 7 of the friends watch football and play football, then Vinay should like football, right? Or if I talk about 20 of the friends, then out of those 20 top 20 friends, 13 friends are playing cricket and 7 of them are football. Then again your decision will change. Okay, Vinay should like cricket. So based on the number of neighbors, the distribution changes, right? So we will also look at how to decide which value of k to take, like how to decide to reach to a value of k. Right now, if I do the value of k is equal to 10, it becomes like this. And when I go to when I look at 50 neighbors, it becomes more clear. Like a particular straight line can define these two distributions, right? Now some pros and cons. Like it is very simple, like so there is no much nothing. Mathematics also is very easy, and to understand this thing, the concept is very intuitive. Like I can just say, yeah, it should work, because neighbors you are defined by your neighborhood. Like training is trivial, training is also very easy, works with any number of classes. So you can have like you suppose in your data you are talking about different kind of sports, Then you can look at different classes like 2, 3, 4, 5, 10, any classes you can take, right? Easy to add more data. So like you can add more data to your predefined model, and they have just few parameters. What is the number of neighbors? What is the distance from all the points? Now cons, high prediction cost. So to predict where it should belong, it has a high prediction cost. High prediction cost in terms of you have to find a distance from all the points. It is like kind of computationally heavy, and it is not good with high dimensional data. Right, suppose you have a data point which have like what 20 parameters. So your distance will become not just x1 minus x2 whole square plus y2 minus y2 minus y1 whole square plus z3 minus z2 minus z1 whole square plus a2. Like there are 20 parameters, so you have to find a distance in 20 dimensions, not just 2 dimensions, right? And this becomes difficult because you cannot imagine that. If so, a point is close in 10 dimensions, but in other 5 dimensions it is far away. You cannot imagine that. So, and it also becomes difficult or like not good with higher dimensional data. And categorical features don't work well. Suppose your features are categorical, right? You do not have a integer value, then it becomes a failure, right? Suppose your categories are like this one, mathematics. Your features are like the like good, bad, and high. Good, bad, best. Good, better, best. Like in terms of categories, you are having some orders: high, low, and average. So how can you find distance when your x-axis is high, low, and average? So in that case, it does not work well because you have to convert. We have seen we have to convert. We have to do one-shot encoding. So in case of low, medium, and high, I have to assign it to 0, 1, 2, or 1, 2, 3, like that. I have to convert it into a numerical scale so that I can find distance from that. Okay, it does not work well in that feature. So let's just to summarize. So these are two classes, and there is a new data point. I want to assign it to these two categories, either category 1 or either category 2. So after I apply KNN, I will get a category assigned to this particular boundary case, right? So if the point was supposed to be here, then it is easy. If the point is here, it is also easy, right? But if for any boundary cases, we make use of KNN, right? So iterating, just go through the algorithm once more. Like choose the number of neighbors, take the k nearest neighbors of the new data point according to the Euclidean distance, right? Among these k neighbors, count the number of data points in each category, assign the new data point to the category where you counted the most neighbors, right? Same. So just look at the number of friends, 5 friends, that is the value of k. Take the nearest neighbors to the of the new data point according to the Euclidean distance. So I defined I will look at five friends. Then I will look at only the 5 closest friends of Shri Krishna, right? That will be my based on Euclidean distance. Or in our case, I will just ask who are your best friends, right? Among these k neighbors, count the number of data points in each category. So suppose I want to look at who likes cricket, who likes football. So out of those 5 points, I will say I will ask all of the friends what is your favorite game. 2 of them says cricket, 3 of them says football. Then I will say assign new data point to the category where you counted the most neighbors. So in our case, the most number of votes goes to football. So I will say Sri Krishna will also like football. He's also a football fan, right? This is a simple algorithm. So this is just a simulation to see how it works. Suppose like the number of k of neighbors is 5. So I will look at 5 neighbors of this particular point, right? By using this particular formula, distance from the 2 points, right? X2 minus x1 whole square plus y2 minus y1 whole square to whole to the under root, right? This is the same distance formula for your revision. I put it here. So for a multi-dimensional case, it will look like this, right? N-dimensional space, x2 and xn. So my distance will look like this. Now among these k neighbors, count the number of data points. So like these are the 5 neighbors, and I found that 3 of them belong to category 1 or football, and like these 2 neighbors belong to category 2. I will assign this to the red category or the category 1 or football because I have higher number of votes from these classes, right? So it is just a like normal. Do you have any doubt? Okay.
No, sir. Actually, we did this, sir. I don't know. I remember we did this.
We did this. You have seen this, Shri Krishna. This presentation you have seen.
Yes,
I don't
sir.
know if you have seen this exact presentation because I have made some changes. This thing you have not seen. You have seen like this one, this thing you have seen.
Yes, sir. Yes, yes,
This
yes.
I have added from, like, because in that we have not discussed about the distance part, right?
Okay.
So yeah, so like there is one more class difference is there, which is like, so one thing is you can so talking about the metric, you can either look at the distance, you can look at correlation, then there is something called like so cosine similarity or Jacquard similarity. So just you like, we will not be covering these three in this course because you have heard of correlation. So either you can take correlation into account, or normal distance between x2 minus x1, or this thing cosine similarity or Jacquard similarity. But you should know, like, you can use any measure of proximity to find the neighbors, right? So like, just like to look at the neighbors of Shri Krishna, I can either directly ask him what are your best friends, or I can just say, okay, the nearest houses, call me 5 people, and based on their best sport, I can define your sport. Or I can go to his class. So his best friends may not belong to his particular section in the college, right? They can belong to some different branch. But if I say, like, the people who you sit with in your class, I will talk to them, and based on them I can define. So these are different measures of proximity. Similarly, we have, like, either I can have a distance, I can have correlation, I can have cosine similarity, or I can have Jacquard similarity. Next, the one more thing that we can do in is that I can assign weights. Okay, suppose I'm talking to 5 friends of Shri Krishna about their favorite sports, and I will say that friend A, B, C, D, E. So friend, whatever the friend A says has a weight of 20%. Whatever the friend B says has a weight of 30%. Whatever the friend C says had a weight of 10%. D also has a weight of 10%, and the other friend has a weight of 40%. Last friend, right? So I will just multiply whatever their vote is by that weight. So it will be a weighted k nearest neighbors, right? So we can, so like currently in this, on the left side of the diagram, all of the votes have equal values, right? All of them has equal, they contribute equally to the vote. But when I assign weight, then I need to take into account the weighted average of the votes. Okay, just this one is a difference, right? So we are done with this presentation. We have 2 minutes. Let's just try to go through the code. Okay. Yeah. So I think we had gone through this particular code. Okay. Yeah, survived. So we have gone through the logistic regression code. Let's look at k nearest neighbors, right? So like we are working with so we, for this particular case, we are working with a randomly generated data, because we want to work with distances. Like for our understanding case, we are working with a random data,
Can you hear me?
right? So yes, Sujan.
That logistic, I think we have not gone through with the data.
So like we went this to very quickly. We'll do it again today only, right? So
Okay,
let me
okay,
just,
not
because like we have recently studied KA, so let's complete KNN, right? So we'll import, like, same thing, same step. We'll import all the libraries. We'll get data from our data set, right? And this is what my data looks like. It's a randomly generated data with a target class. So this particular row belongs to class 1, this particular row belongs to class 0, or maybe like it is cricket, it is football, whether it is like a cat or dog, anything. 2 classes are there, right? And this is the data based on the parameters I want to calculate the distance, right? So next step is standardize the value, like we have seen in the introduction class to machine learning. So to standardize, I will do sklearn dot preprocessing import standard scalar. Standard scalar will convert all of them into like standard scale, normal scale. Normal means that z transform, right? So I will, for all the scaled features, I will do the scalar dot fit for to all the features. That means I need to drop target class, right? Because I don't, because this is my target class. It's not a feature. This is like whether it's a spam, whether you have cancer or not, or like it's the class I want to predict. So I will remove this class from my this particular data frame. For all other columns, I will transform, right? Scalar dot fit. So I will do scaled features is my new variable which contains all the transformed or standard parameters. Guys, let me stop this and start the new meeting because it's already 1 minute, less than 1 minute, right?
Okay.